Okay, so the next figures, like I said, we're going to focus on quadrilateral-wise is going to be the trapezoid. So today, this lesson is all about now the trapezoids, okay? So again, this yellow one is a picture of a trapezoid. Maybe to save time, let me talk about it. So a trapezoid is a quadrilateral because it has 4 sides. It is not a parallelogram. Notice that these 2 sides are not parallel, but it does have 1 pair of opposite sides. So the top is going to be parallel to the bottom if it's drawn this way. So again, a trapezoid has 1 pair of opposite sides parallel. So we've got arrows on the top and the bottom. So if I write some things down about it, we'll just write in the here. There's not as much to write down about a trapezoid. So a trapezoid has 1 pair of opposite sides parallel. Does anybody know what those opposite sides that are parallel are called? They have a specific name. Starts with a B. Okay, those are the bases. So again, you have 1 pair of opposite sides parallel. Those are specifically called the bases. Now, just another side note. The non-parallel sides are called legs. So again, it has 1 pair of opposite sides parallel, that's your bases, and the sides that are non-parallel, which would be like your left and your right in this situation, are called your legs. Okay, so if I look at this picture at the bottom here, one thing we can add, because the top and the bottom are parallel. Okay, do you remember when we talked about parallel lines? Earlier this semester, if we have, for example, everybody see the letter C here in the picture? The highlighted C? Okay, do you remember what kind of angles make the C? Okay, those are same side interior, and same side interior angles are supplementary. So this angle and this one, they are supplementary. Remember, supplementary means they add up to be 180. Same thing over here. These 2 angles are supplementary. So if I knew one of them, then I could find the other. For instance, let's pretend that this angle here was, let's say, 50 degrees. So if this one is 50, what does this angle down here have to be? If they're supplementary, that means they add up to be 180. This one would be 130 because 180 minus 50 is 130. Okay, let's pretend this one over here was 100. What would this one at the top have to be? 80. Okay, that's really the only thing you can do with the trapezoid is deal with those angles from top to bottom. So these 2 are related and these 2 are related. That's just if it's a plain old trapezoid. Nothing special about it, just a plain old trapezoid. Okay, anybody have any questions about just a trapezoid in general? Okay, am I going too fast? Ready for the second one? Okay, so let's take a look at the blue one. This is still a trapezoid. Anybody notice anything different about the blue one here? Anybody notice anything about the legs? So the bases are still parallel in a trapezoid, but this blue one here is a specific type of trapezoid. It's an isosceles trapezoid. What makes an isosceles trapezoid special is that your legs are congruent. So these 2 legs are going to be congruent. So again, it still has the bases that are parallel, but again, in the yellow one, do these 2 legs look the same length? No, but if it's isosceles, that means they are. Now, another interesting fact about an isosceles trapezoid is angles as well. These 2 angles at the bottom are what we call lower base angles. They are going to be congruent, the same degree. And these ones at the top are what we call upper base angles, and they are going to be the same. So these 2 at the top are going to be the same, and these 2 at the bottom are going to be the same because it's not just a trapezoid, but an isosceles trapezoid. So again, that's what makes an isosceles trapezoid special. So again, it's a trapezoid, so the bases are parallel. Since it's isosceles, the legs are congruent, and then we have what we call lower base angles congruent and upper base angles congruent. Okay, so on the inside, if we list out the properties we were just talking about, so again, since it's a trapezoid, it has one pair of opposite sides parallel. Again, that is called your bases. Okay, you have the other pair of opposite sides congruent. Again, those are your legs. So your bases are not congruent. Your bases are parallel. The legs are congruent. Okay, like I said, you have the upper base angles congruent, the ones at the top. You have the lower base angles congruent. Those are the ones at the bottom. And then we can also state any upper base angle is supplementary to any lower base angle. So again, any upper base angle is supplementary to any lower base angle. So any of them at the top is supplementary to the bottom one. Okay, now we have one more thing we need to add about an isosceles trapezoid. In the bottom picture, we're going to draw it in, but the diagonals are congruent. So again, if it's an isosceles trapezoid, the diagonals are congruent. That does not work in just a trapezoid in general. It has to be an isosceles trapezoid, and if it is, then the diagonals are congruent. So if we draw in the diagonals, I'll move my hand here a second. Okay. So again, if we draw in the diagonals, there would be one going this way, and there would be one going this way. So again, these two diagonals are going to be congruent. So if one's 10, the other one's 10. They don't bisect each other like they do in a parallelogram. In my opinion, you know, this piece here looks a lot shorter than the other part. Okay, but again, the diagonals themselves are going to be congruent. So again, in an isosceles, the bases are parallel, the legs are congruent, the upper base angles are congruent, the lower base angles are congruent. Any upper base angle is supplementary, means it adds to 180 to any lower base angle. And finally, the diagonals are congruent. So if you're talking about a trapezoid, the isosceles one has a little bit more going for it. Okay, so the last thing we're going to look at on the next page before we do the final examples is the median. And it's still with a trapezoid, but we need to talk about how to find it, because that's the only other thing we're going to cover in terms of a trapezoid. Okay, is everybody ready to move on? Okay, so let's move on to our orange one. Okay, so before we look at the examples, let's take a look at this. So this is a picture. The segment in the middle is called a median of a trapezoid. Okay, the reason that's a median is because it's going to intersect at the midpoints of the legs. So I can see that by noticing these two segments are congruent and these two segments are congruent. And for reference, we're going to call this A, B, C, D, E, and F, and we'll work on an example in a little bit here below. So again, this is a median. The reason we know it's a median is because it's a segment drawn that intersects at the midpoints of the two legs. And again, the reason I can show that is because these two pieces with the tick mark are congruent, and these two pieces with the tick mark are congruent. Okay, everybody ready to look at the inside of it? Okay. So on the inside, let's talk about, like I said, let's write down what I wrote down of what I said about the median. So a median of a trapezoid is a segment formed by connecting the midpoints of the non-parallel sides. Parallel sides. And remember, those non-parallel sides are called your legs. So again, median of a trapezoid is a segment formed by connecting the midpoints of the non-parallel sides, which are your legs. Your median is parallel to the bases. So again, it's parallel to the top, parallel to the bottom. And then one final thing, the length of the median is the average of the bases. So again, to find the length of your median, you're going to average the two bases together. So again, just refreshing your memory here. So a median of a trapezoid is a segment formed by connecting the midpoints of the non-parallel sides, which is called your legs. It is parallel to the bases. So the top, the middle, and the bottom are all parallel. And the length of the median is the average of the bases. Okay, so we're going to do a little short example here at the bottom, and then we're going to practice our trapezoid examples to finish off with here. Okay, so I'll pause for a moment to make sure everybody gets everything written down. Okay. Is there anybody still writing at the top here? Okay, so in the bottom part, let's draw in where we think the median should go right here. Okay, so if I pretend the top is 6 and the bottom is 10, and I want to find the median, which we'll call x. Okay, so again, the median is the average of the bases. How do I find the average of two numbers? Anybody know? If I have two numbers and I want to find the average of them, what am I going to do? I'm going to add them and then divide by, how many numbers do I have? 2. So I'm going to add them and divide by 2. So to find x in this problem, I'm going to take 6 plus 10, 6 plus 10, and divide it by 2. So 6 plus 10 is 16. 16 divided by 2 is 8. Now, some of you could just do it thinking, what's in the middle between 6 and 10? 6, 8, 10, right? Some of you could do it without the formula, and that's fine. But again, to find the median of a trapezoid, it's the average of the two bases. It's in the middle. Think of it that way. Just like the median of a road, right? Talking driver's ed is in the middle of your road, right? The median of a trapezoid is in the middle here. Okay, anybody have any questions about this example? No. Okay, so let's look at the last page of our notes. Let's practice doing these problems. Make sure we're good to go to be working on our own here. So again, all 9 of these examples deal with a trapezoid, okay? So on number 1, it says, find the measurement of the angle indicated for each trapezoid. So number 1, it shows that angle W here is 105 degrees. How do I find angle V? How are these two related? So top, how's the top related to the bottom? They're supplementary. So to find this angle V, I'm going to take 180 minus 105. So what's 180 minus 105? 75. So my missing angle V is going to be 75. They are not congruent. They are supplementary. If you need a calculator today, that is fine. Okay, let's look at number 2. What kind of trapezoid is this one? Is it a special trapezoid? What's true about the legs here? They're congruent, right? So that means it's an isosceles trapezoid. In an isosceles trapezoid, however, are these two angles related? They're lower base angles, so they are the same. So what's angle B going to be? 80. So again, you got to realize what you're looking at in the picture. This is a picture of specifically an isosceles trapezoid because the legs are congruent. If that's the case, the lower base angles are congruent. Okay, this one I particularly put on here because it has an X in it, just to make sure we can handle that. So it says solve for X, and again, each figure is a trapezoid. So in number 3, again, this trapezoid is special. It's isosceles because it has two congruent sides. So if angle F is 105 degrees, what's angle E going to be, degree-wise? 105. So if I'm going to find X, I'm going to set 17X plus 3 equal to 105. Because again, this angle here has to be 105 because this one is. So if I'm going to solve for X, the next thing I would do would be to subtract 3 from both sides. So 17X is going to equal 102. And then to finish the problem, I'm going to divide both sides by 17. So what's 102 divided by 17? 6. So X is going to be 6. Again, it's the same kind of concept as above, but we're just practicing with it so we can find X. Okay, let's take a look at number 4. How are these two angles related? Are they the same? They're supplementary. So what I'm going to do first is let's find what angle T is. So to figure that out, I'm going to take 180 minus 114. What is that going to give me? Anybody know? 66, right? Okay, so to find X, I'm going to set 30X plus 6 equal to 66. That angle here is not 114. It's going to be 66 degrees. So if I'm going to solve for X, I would subtract 6 from both sides. So 30X is going to equal 60. And then to finish it, I could divide both sides by 30. So X is going to be 2. Okay, so again, you got to think, are the angles congruent or are they supplementary? Once you make that decision, then you should be able to write an equation to figure out what X is going to be. Okay, let's take a look at number 5. This one says find the length of the median. Remember, the median is the average of the bases. So if I'm going to find the median in this problem here, I'm going to add the bases, 20 and 30, and divide by 2. Or some of you know what's in the middle between 20 and 30? 25, okay. If we work it out, what's 20 plus 30? What's 50 divided by 2? 25. So whether you use the formula or you just think, okay, what's in the middle between 20 and 30? It's 25, whichever works for you. Sometimes it's not as obvious just to think through it, so you're probably going to want to use the formula. It just depends on you. Okay, now let's take a look at one where they don't want you to find the middle, where you want to find one of the ends. So you know the top base is 8, the median is 11, and I want to find the bottom base. Okay, so how do you get from 8 to 11? You're going to add 3, right? So that means 11 should be also 3 away from the other base, right? If it's in the middle. So what's 11 plus 3? 14. Everybody see how I did that? To get from 8 to 11, I had to add 3. So to find the other base, it's got to be 3 away as well. So 11 plus 3 is 14. Okay, I'm not trying to go too fast. Okay, so let's look at number 7. This one's same kind of problem, but with X's in it. So if the top base is 9 and the median is 13, let's figure out the bottom base first. So how do I get from 9 to 13? I add 4. So my other base should be what number? 17. So this bottom base should be 17. So I'm going to set 4x minus 23 equal to 17, because the bottom base, based on my calculations, should be 17. 9 plus 4 is 13. 13 plus another 4 is 17. So that's why I'm going to set this 4x minus 23 equal to 17. So if I'm going to continue solving for x, I would add 23 to both sides. So 4x is going to be 40, right? So if I divide both sides by 4, x is going to be 10. These are not necessarily difficult problems, okay? You just got to figure out how everything is related, maybe is the tricky part for some of you. Okay, so we've got 2 left. Okay, so let's look at number 8. It says, find the length of the diagonal. Well, notice, it's an isosceles trapezoid, and we said in an isosceles trapezoid, the diagonals are congruent. So if DB is 6.4, what's EC going to be? Yeah, 6.4, because again, the diagonals are congruent. They're going to be the same length. Okay, and the last problem here on the examples, it says WY is 21. So WY is a diagonal. So how long is XZ going to be, first off? 21. So I'm going to set 13 plus X equal to 21, because if one diagonal is 21, the other one's 21, because it's an isosceles trapezoid. So to solve for X, if I subtract 13 from each side, I get 8. Good. So X is 8. Okay, so that's it for a trapezoid. So we've got trapezoids and isosceles trapezoids along with their medians.